Hello everyone. Hope you all are doing well. So today we will continue with the sequential circuit. In earlier lecture we have discussed different latch SR latch made with NAND gate as well as NOR gate. Then the flip flops SR flip flops, JK flip flop, T flip flop, and D flip flop. Now in continuation with that, today we will discuss some more important terms like race around condition, master slave flip flop and all. So as we know that flip flop is a edge triggered circuit, sequential circuit. So uh, this portion is your latch. This is your SR latch using NAND gate. Now to make this a flip-flop, we add two circuitry, this edge detector and this steering circuit. Now this edge detector is used to get a signal, a small periodic signal, triggering signal, which can be used to drive this SR flip-flop. Means we are not interested in this complete level either 1 or 0. We are interested in the edges either 0 to 1 or 1 to 0. So we are using edge detector for that. Then the steering signal just drives this clock signal to this latch. So what is this edge detector? So this edge detector produces a narrow positive going spike clock bar. Here we are getting a narrow positive going spike that occurs with coincident with the active transition of the clock input. Means this pulse is synchronized, this narrow pulse is synchronized with this clock. So and we are considering it for the positive edge triggering. So this is the circuit for edge detector for positive edge triggering. So we have connected a NOT gate here, and this we are directly giving this clock to this AND gate and this clock bar through this inverter. So and finally we are getting this clock star, this narrow edge. So how this works? So this inverter will have some finite delay. So suppose this clock is initially 0, so at this instant it is going high. So this clock bar will not go low at this instant only, rather it will go to 0 after some delay, which is the delay of this inverter. So at this after this delay it is going 0. So we know that for the AND gate output is 1 only when both the inputs are 1. So this clock bar and clock is 1. So in that case only for this much duration this clock is 1. For the this remaining period this is 0. So this much for this much spike, this is within 2 to 5 nanoseconds. So this is similar, almost negligible. So this is similar to the edge only. So it will work at the positive edge. Similarly for this negative edge triggering, so here what we have done, we have just used this AND gate with both the inputs inverted. So what will happen? Suppose we have taken clock, initially clock is at 0. So at this instant it is going high. Now this clock bar will go to 0 after certain time duration, this delay, it will go to 0 after this. Now again when this clock is going to 0, so this clock bar will go to high after a certain time duration. Now as this is both are inverted, so for this clock star to be 1, we require that output of these bubbles should be 1. So here only this clock is 0, so after this bubble here this will be 1, and this clock bar after inversion will be 1. Both are 0, so after bubble both will be 1. So at this point this clock star will be 1. So this is a small spike. So that means this is activating only at the negative edge of this clock signal. So this is used for negative edge triggering, this is used for positive edge triggering. So this is the explanation of this. Now coming to D latch, or what we call it a transparent latch. We have read SR latch. So another type of latch where we can join both S S is connected to D and R is connected to inversion of this D. So that condition S equals to R equals to 1, invalid state will never come. Okay, so this is just the D flip flop without the clock. We are using, rather than clock, we are using enable signal, which is level triggered. So it will go into two modes, transparent and latched. In transparent, this enable in transparent case, enable is 1. So when enable is 1, so it will work as a D, normal D flip flop, you can say. So what it will have, it will have whatever D input you are giving, same will be the output. So this means transparent, whatever you are giving, same is reflected on the output. So enable is 1, Q output will look exactly like D in this mode. So D latch is said to be transparent. Now the when enable is 0, so when enable is 0, so it will hold its previous state. So it will hold its previous state. So the outputs are latched to their current level and cannot change when enable is low, even if D is changing. So when enable is 0, that means this is these outputs will be previous outputs only. So even if you are changing D, so then also this flip flop output will not change. Now coming to some asynchronous inputs. As we know, in the flip flops, like suppose we have taken JK flip flop. So even if only when this clock is triggering, that means if here we have taken bubble, so that means we are considering negative edge triggering. So until and unless this clock is going from 1 to 0, only at that point the change in JK input will be reflected at the output. Otherwise, if clock is not triggering from 1 to 0, so it's this even if you change these JK flip flop, the output will not change. So that means these inputs J and K are synchronized. These J and K inputs are synchronized with the clock. Now two special kind of asynchronous inputs are used: preset bar, clear bar. So this bar and this bubble shows that these are active low inputs, and these are asynchronous. That means these are independent of clock. Even if you are not, whatever is the condition of clock or whatever is the condition of JK value inputs, so according to these preset or clear, the flip flop will work. Suppose this preset is equals to 0, that it is active low. So when this preset is 0, that means it is enabled and your flip flop will set. Similarly, when clear will be 0, so that means it is active low, so the flip flop will be reset, independent of the values of J and K and clock. So these are, therefore we call these asynchronous or override inputs, means these are independent of the clock, not synchronized with the clock. We can see here. So whenever this preset and clear are 1, these are active low, so 1 1. So then in these cases, this preset and clear are disabled, so it will work as according to JK and clock, these will work. Now when this preset is whenever this clear is 0, whatever will be the case of this JK or clock, this will be 0. Then whenever this preset is 0, then it will reset in independent of the values of the JK. And whenever both are 0, so both can't be 0, both is 0, that means both preset and clear are 0, so that means invalid condition will prevail. Now coming to race around condition. Now race around condition occur under these conditions when J and K flip flop, in the JK flip flop, both J and K are equal to logic high. Other thing is the delay of the flip flop is less than the on period of the clock, and the other thing is when level trigger is applied. So look at this, that this JK is 1 and we are applying positive level triggering. So this is the clock. So initially we are taking that output is 0. So on the when this clock is going from 0 to 1, so this is enabled, so it should toggle at this point, but this delay, this delta t, it will toggle after this delta t, because it has this propagation delay, so it will toggle at this point. Now as it has toggled at this point, so again it is saying a enabled level of one level, high level of clock, so again it will toggle but after a delay. So it will keep on toggling during this finite on duration of clock. So in this situation we are not confirmed whether it is keep on toggling, it is race around condition is this only, it is going to 0 then 1 0 1 0 1. So what we can do, we can resolve this race around condition through uh, three methods. One method is increasing the delay of the flip-flop. We can increase the delay of the flip-flop. If we increase this delay del t of the flip-flop more than this on period and less than this whole time period of clock, it should be less than time period and it should be greater than t on. Then this, suppose here Qn is 0 initially, so it should toggle at this high level, but it will toggle after a certain time delay, so it will toggle at this point. Now it has toggled here and now it has skipped the high level of this clock, so it will maintain its value, previous value. Again at this point it is again seeing high level of clock, so it should toggle, but it will toggle after this duration del t here also after delay, which is more than this t on. Then it has toggled here. Now at this point when it has toggled here, this clock is disabled, so it will remain as it is. So in this way we can see that it is changing, this race around condition is removed and it is at a particular instant it is toggling. But the disadvantage of this method is that we never want our unwanted delays in our circuit, because delay is inversely proportional to speed. More the delay, less is the speed, so we always want high speed circuits. So we this in increasing the delay is not a good option. So what we will do, the second thing we can use is use of edge triggered flip-flop. That thing we have discussed, edge detector circuit. So we can introduce that circuit. So if the clock is high for a time level interval less than propagation delay of the flip-flop, then racing condition can be eliminated. This is done by using the edge triggered flip-flop rather than using the level triggered. Okay, so this is the second option. The other option is use of master slave flip flop. So what we do in master slave, we use two flip flops. One is master, other one is slave. So each flip flop work for a particular edge, for a particular level of the clock. As a whole, we are using two flip flop. That doesn't mean that we are storing two bit. This is used for 1 bit storage only. So how it works, let's see. So this JK flip flop, this is master, this is slave. So this one is activating at clock 1 and this one is activating at clock equals to 0. When clock will be 0, so here clock bar will be 1, so it will be enabled. So when suppose this JK is, both inputs are 1, suppose this JK input we are giving 1, so at this point, uh, this is positive, so at this point master will work but the slave will remain as it is. So slave value, so the final output, this output is in the previous state only this intermediate, this output will change. So it suppose this they have taken the condition, I guess j k, j is 1 and k is 0 because it is setting, or previous condition only. So that means this for this one, this master flip flop is working. Then for the negative one, this will hold its previous value, but it's the slave will work according to the values which you have taken during the positive level of this clock. So here we have at this point qm is 1, So QM is 1, this is 1, this is 0. So 1 0, so 1 0, so J is 1, K is 0. So here J is 1, K is 0, so set. So QS is set. So at this point it will be disabled, so it will maintain its previous value, while this master will work according to the inputs, initial this input JK input. So if JK input here, this is reset, so suppose J is 0, K is 1, so it has reset. So in this way it will work. So overall this is the clock, this is the final output. So you can see that at the negative edge of the clock only the output is toggling. So when you are connecting the slave with the negative, so that means you are working on negative edge trigger. So this way, through master slave flip flop, you can remove your race around condition. Now coming to conversion of flip flops. So in many cases we have to convert one flip flop to another. Suppose here we have taken the example SR flip flop to D flip flop. So what you can do, you can combine two this table, characteristic table and excitation table of these two flip flops. What you do, so you are changing SR flip flop. So you have SR and you have to add this D to these SR. So what you will do, you will write the excitation table of the flip flop which you have, and you will make this, you will add this column to form the characteristic table of the flip flop which you have to, in which you have to convert. So this way then you will you will find this D in terms of you will find this S, actually S in terms of D and Q. So this S is enable high at this condition 1 0 and 1 1 don't care. So this 1011. So S in terms of D will be S equals to D. Similarly R will be equals to D bar. So if you have SR, so what you will do, if you connect this S to D and R to D bar, so this SR flip flop will convert into D flip flop. So in this way you can convert one flip flop to another. So this much for today. We have discussed all race around condition, master save, flip flop and other things. So in next lecture we will go to the applications of flip flop. Thank you.